Hello and welcome. In this bonus video, we are going to talk about absolute value and how that ties to the idea of a linear function. So our objective for this lesson is I can write an absolute value function as a piecewise function. So let's go ahead and jump right in. So the parent function for the absolute value graph is just the function f of x equals the absolute value of x. And if you remember from previous classes, when you graph that, it makes sort of a V shape. So something I want you to think about that you may or may not have ever thought about before, but did you ever notice that the parent function for the absolute value is really just two lines? I mean, think about it for a second. That V-shaped graph could have one line on the left that has a negative slope and one line on the right that has a positive slope. So how is this a helpful observation? Well, that means that if we have an absolute value function like this one, we could actually rewrite it as the equation of two separate lines. This is going to be incredibly helpful when we start doing calculus with functions like absolute value, and it directly ties to fields such as physics. So let's think about this absolute value function. It has a vertex at the point 0, 0. We can see that here. And then to the left, there's one line, and that line has a y-intercept of 0 and a slope of -1, and a line 2 to the right, which has a y-intercept of 0 and a slope of +1. So the vertex is at 0, 0, and the lines are line 1, y equals -x, and line 2, y equals +x. So how do we write this as a piecewise function? So f of x is equal to the absolute value of x, which we could rewrite as the line -x, as long as x is less than or equal to 0, or the line x as long as x is greater than 0. So this is representing line 2. Now, the or equal to sign could be with both pieces of this piecewise function, since they both have a y-intercept of 0. It could be with this one, or it could be with this one. I like to just tack it onto the first one if it's going to be the same for each piece. So for a typical absolute value graph that has two linear pieces, as long as we know the vertex, we can find the equation of the line and then take the opposite slope for the negative version of that equation of the line, and we can split that into our two pieces of a piecewise function. So let's look at some examples. So here we have the absolute value of x minus 1 plus 2 is our function. So how is this different than the parent function? Well, it has moved 1 to the right and 2 up. So the vertex, instead of being at 0, 0, the vertex is going to be at the point 1, 2. What that means is in our piecewise function, the x's are going to change what's happening at x equals 1, as opposed to the last example where it was changing at x equals 0. So the slope is going to be negative until we get to x equals 1, and at x equals 1, it's going to change to be positive. So I'm going to go ahead and label each of these lines as 1 and 2 so we can talk about writing the equation of each of those lines. Now, line number 1 is going to be the negative slope. So the part that's going to be negative is going to be the piece that affects my x value. So for line 1, I'm going to be looking at y equals the opposite of x minus 1 plus 2. And this negative sign here is because right now we're looking at the negative slope of this line. So let's go ahead and simplify that. And we get y equals -x plus 3. Now for line 2, we're going to do the exact same thing, except we're not going to need to take the opposite because this line already has a positive slope. So now we have the two pieces of our piecewise function. And just to be sure we're right, if we plug in 1 to both of these pieces, we should get 2. So if I plug in 1, I get 2. If I plug in 1, I get 2. So let's go ahead and set this up as a piecewise function. The first piece of our piecewise function is going to be -x plus 3. And this is true as long as x is less than or equal to the x part of the vertex. I'm going to put a semicolon less than or equal to +1. After we get to +1 and we start going up in our x values, we're going to be using the line x plus 1 for x greater than 1. Let's go ahead and look at a few more examples. So if you think you're ready, I encourage you to go ahead and jump into number 1 on your own. Find the vertex, find the equation for line 1, find the equation for line 2, and then rewrite it as a piecewise function. If you're not quite ready yet, let's work through this example together. So pause the video if you're ready to work on your own. Otherwise, Listen along with me. Okay, so the vertex for this particular graph is going to be at -1, 0, because -1 would make the inside 0, and there's no vertical transformation moving us up or down. So in our piecewise function, when we're eventually going to write that, this is going to be for x less than or equal to -1 and for x greater than -1. Now we just need to find the two pieces. So for the first piece, we're going to take the opposite of what we see inside absolute value. That's going to give us -x minus 1. For the second piece, the second line, we're going to keep it exactly the way that it is right now. So that's going to be x plus 1, and we have our piecewise function. Here's our next example. So if you haven't tried one on your own yet, go ahead and do so. I'm going to give you a hint. If you're stuck, the vertex is going to be the x value that makes this inside piece 0, comma 0 in this case, because there's no vertical translation. All right, now go ahead and try this one on your own. All right, hopefully you've had time to work through this, because I'm going to put up the solution, and here the solution is. So if you didn't quite get this, or if you need more time to check, pause the video, check over your solutions, and I'm going to put 2 more practice problems up and encourage you to try them on your own. All right, I'm going to encourage you to try these 2 problems on your own. One tip I want to give you, or one thing I want to point out, number 3 is extra tricky because there is a negative here. What does that mean about your graph? It means that our graph is going to open down, so an upside down V, which means that line 1 is going to have the positive slope and line 2 is going to have the negative slope. So just keep that in mind. Watch out for that reflection. And then see if you can work through these 2 piecewise functions, or turning these 2 absolute value functions into piecewise functions on your own. So here are the solutions to those 2 sets of problems. Pause the video so that you have time to check over them and note any questions you have. And then we're going to talk about one last thing before we wrap up. So let's just briefly wrap up by talking about piecewise functions in general. So first of all, let's look at an example so we can talk about what they are. So a piecewise function is just a function that's defined by different pieces. So it's pieces of different functions put together, hence the name piecewise function. So here is an example of a piecewise function. For all values of x less than 0, we use this linear piece. When x is equal to 0, the function is 2. When x is greater than 0, we use this quadratic piece. So let's see if you can use the function notation to find some particular values of f. All right, pause the video, find f of 0, f of -2, and f of 1. So hopefully you gave yourself enough time, otherwise pause the video, and you can see the different pieces, the different x values that get plugged into the different parts of the function. Now let's go ahead and sketch a quick graph of this function. So we're going to sketch the purple piece first, the line for x less than 0, so we're going to have an open circle at 0, 1, because if I plugged 0 in, I would get 1. So let's go ahead and graph the line. So there we have our line, y-intercept 1, slope 1. Now, when f is 0, we get 2, that's the green piece. And the red piece is going to be our quadratic, which I'm going to sketch now. So really, it's just like you're graphing 3 separate graphs because there are, in this case, 3 separate pieces. So let's recap what we covered in this video. All right, so in this lesson, we extended the idea of linear functions to absolute value, and we learned how to write an absolute value function as a piecewise function. Go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.